Okay, in this video, I'm just going to show basically um, where the area for a circle formula comes from. So, area of a circle, you probably remember this from previous grades, and that's just pi r squared. Okay, and that relates directly to what you see here in EQ2. So, that's what this video is going to be about. Um, and first thing we see are not very circle like, right? So here we have n equals 3. This is a regular triangle, right? It's a regular hexagon. And we notice this angle becomes wider. We also notice that the distance from the radius to the apothem gets closer as n gets larger. So we went from n equals 3 to n equals 6, and those are the changes that we see happen, right? Then we go from n equals 6 to n equals 8. Not so obvious exactly what happens. Okay, not so obvious exactly what happens, but we still see we have a wider angle. Okay, so we get slightly wider here, right? And we see that our radii gets closer to our apothem, right? And we also see, of course, theta regular itself, right, also gets larger. Okay, so now we're going from n equals 8 to n equals 12. Okay, so this is pretty drastic. We can see this. So we're going from 3 pi over 8, getting even wider to 5 pi over 12. Distance from radius to apothem gets even smaller, right? And obviously, well, theta regular is getting super wide. Okay, so what's happening is theta over 2 is approaching pi over 2, right? So theta over 2 are these angles here. Okay, and theta regular is approaching twice that. It's approaching pi. So we're getting closer and closer. So you look here, we're getting closer and closer to approaching just a flat angle, which would just be 180 degrees or just pi, right? So what does this mean? Well, as the apothem gets closer and closer to just being touching the radius, right? We can go ahead and say that the apothem just is the radius when we look here at an infinitely sided regular polygon, aka a circle, right? This is where n would be approaching infinity. I can't say that it equals infinity, right? Or else all the math elites will come try to fight me. Anyway, so that's happening. Okay, so now let's think about our formula for the area of a regular polygon. Okay, that is simply apothem times perimeter divided by 2, right? Well, if the apothem is approaching r, our radius, which is what we see right here, going from here to here, right? We see that apothem and radii exist in the same spot. And our perimeter, well, what's the perimeter for a circle? Well, duh, that's just 2 pi r. That is the same thing as circumference. Exact same thing. Okay, and then all divided by 2. We rearrange some things. We see that we have r times 2 pi. The 2's will cancel. R times r is r squared. And there you have it. We have pi r squared, the area of a circle. Okay, so let's look at a few examples. So say we had a circle and we didn't know the radius, but we knew the circumference was, I don't know, 50 meters, right? That's the circumference. That's the distance all the way around. That's the perimeter of the circle. Okay, and I want to know, well, duh, what is the area? Okay, well, we don't even know the radius, right? But of course, we can easily figure that out. Okay, so circumference equals 50 meters, or 50 meters equals 2 pi r. Okay, so throw that in our calculator. All we're going to do, obviously, is divide both sides by 2 pi. Okay, so that would be 50 divided by 2 times pi. And that gives me 7.98. So radius is about 7.98. Now I have all the info I need. to calculate the area of the circle. Pi times r squared, so 7.98 squared. Okay, and I'm just going to throw that in here. So pi times the radius, let's copy and paste here, squared, and I'm done, 198.94. So the area of a circle with a circumference of 50 meters is 198.94. And that would be meters squared, because we're in meters. Okay, let's do another example. It's a little more straightforward. So we've messed with this before where we don't know the radius. Okay, I just want to really make sure we understand how the formula works. Okay, so let's say we did have the radius. Okay, let's say we did have the radius. The radius was equal to 10 miles. Okay, now we don't need to do anything fancy. We know the radius. We're just going to plug in pi r squared. Well, 10 squared is 100, so I can just say the exact area of this circle is 100 pi miles squared, right? Which is approximately, then we need the calculator, 100 pi, 314.16. And that, of course, would be miles squared. Okay, so simple stuff, man. Okay, nothing too difficult. And you also got to see where the area of a circle comes from. Okay, so like always, if you have any questions about anything, shoot me an email. Otherwise, you know where to find me. Goodbye.